Hey, good morning all. Welcome to this webinar today with Topcon Solutions and our Autodesk partners at InfoDrainage, reducing complex drainage design with InfoDrainage. And so I'm Nate Philbrick and I'm on the Topcon end. So I'm an application solutions engineer at Topcon. And so think of me as the hydrology lead here at Topcon, and we're going to have Midori over at InfoDrainage, who's going to be sharing some InfoDrainage tips and tricks and some good things we can do with InfoDrainage. So a little bit about me and my background. I'm an AEC solutions engineer at Topcon. I'm an Autodesk certified professional and instructor for Civil 3D, and also kind of in part with my Civil 3D, I'd like to pilot drones, and so I'm an FAA drone certified pilot. And what do I do at Topcon? So basically anything post-purchase, maybe a little bit of pre-purchase sales. I really teach a lot of our EITs and users trying to understand how to use Civil 3D in the infrastructure products. I implement certain workflows. So one popular one that we're having right now is collaboration for Civil 3D. So migrating firms from a server-based environment up to the construction cloud. And lastly, consulting. How can we optimize our workflows? What can we do that could be better for us? And take a look under the hood, so to speak, and let me know how our firm's working, if there's anything we can optimize. Previous to my time at Autodesk, I was an infrastructure specialist at Autodesk, so it's been pretty cool. So I'm seeing things, I guess, where the sausage was made, and a little bit now on the partner side of things. And in my personal interests, I live out in Portland, Oregon, in the southeast, and I like to skiing on Mount Hood, mountain biking, and whitewater kayaking in the Pacific Northwest. All right, so a little bit of background about Topcon, what we do, who we are, and introduction to Topcon Solutions Store. So Topcon Solutions Store is a branch of Topcon positioning systems. So you might have seen our hardware devices, those GPS devices, our machine control on construction sites. That's our real core business at Topcon. And then within the Topcon Solutions Store aspect of it is the software department and the Autodesk software. And so one thing that we're a part of at Topcon is really creating this full workflow, a field to finish, collecting your survey to design to construction, and being with you every step of the way for that entire process. Can you hit the next slide there, Midori? All right, and so a little bit about where we are in the United States. So up in the upper left, you can see we have two locations. So we have one location in Kent, Washington, another location in Portland, Oregon. And then we also have our other 11 locations sprinkled through the Midwest and on the East Coast. And just for some of our devices you may have seen, so we make a lot of hardware, and a lot of them, optical instruments, GNS receivers and antennas, collecting that survey data, construction machine control, laser instruments and receivers. So a lot of those hardware products you've seen on construction sites. All right, and just a bit about our vision, who we are, like I was alluding to on a couple slides previous. So really that field to finish workflow. So survey to design to construction. And now I'm going to be handing this off to Midori, who's a solutions engineer at InfoDrainage, and she's going to be taking us through InfoDrainage to give us an overview of the product and tool. It's a really exciting platform because Autodesk made a giant acquisition for this last year, and I'm really excited to hear what Midori has to share with us today.
Thank you, Nate. Yeah, like you said, I'm going to be talking about drainage design with our drainage design product, which is called InfoDrainage. Before I dive into it, I'll give a brief introduction. My name is Midori Patterson. I'm a solutions engineer here at InfoDrainage, part of Autodesk, and I've been here for about 7 months. Before joining Autodesk, I was in engineering consulting doing water resource engineering, so a lot of floodplain and hydraulic modeling, and before that was doing some drainage design as well. And so I'm excited to be here today and to be able to talk to you guys about this product. And before I get into the specifics of the software, I'll start with a couple high-level slides, beginning with identifying some key challenges that we focused on addressing with the conception of InfoDrainage. And so these are everyday problems, and they're not necessarily new problems, but they're themes that continue to evolve in the drainage design space. So first of all, we need to be able to track different aspects of the drainage design across multiple packages. You'll hear me talk about bringing a design from concept to construction a few different times in this conversation. And we know that we can't complete our drainage designs in a vacuum, and never has data been more important. So having a platform to make use of any supporting data as well as share that data is key. Secondly, as we move through the drainage design process in terms of either iterations or phasing or level of detail, we often have to recreate design data from one format to another if we're using traditional methods. This recreation of data is mind-numbing, it's annoying, it's time-consuming. And it's also a design integrity issue, really. So every time that you're manually typing in a number, you're introducing that risk of human error. So a third challenge is that we need to demonstrate compliance to local standards, and there might be some drainage design purists out there who love drainage design, would do it for free, even if they didn't have to, but most of us do it because we have to. And those local standards vary based on jurisdiction. Everybody wants it in their own particular format, and regulatory agencies ultimately need to be able to trust in the designs that you submit and ensure that it's not going to have a negative impact in their communities. And sometimes as you're dealing with those local regulatory agencies or just with different stakeholders, you might be dealing with someone who doesn't have a technical background, or your drainage design is just really complex. And so that brings us to this fourth challenge, being that drainage designs can be difficult to communicate. And so when that happens, when people or stakeholders aren't understanding your drainage design, that can cause project delays, and that can affect consulting engineers' margins and credibility. So making sure that we can convey those complex designs true to site, on plan, to inform technical and non-technical stakeholders alike is really important. And lastly, adding to those layers of complexity, we're at a time in the industry where there is this shift towards green infrastructure. And so these elements can often be a little more detailed, a little more nuanced in nature, and you need more of them spread throughout a site, which, if not handled correctly, can really throw off your overall organizational workflows and your calculations for how the system as a whole will function. I'd like to also talk a little bit, just kind of another high level thing about the fact that historically drainage design was about sizing pipes to take excess stormwater flows from a site. But kind of like I mentioned earlier, there is this industry shift towards a greener approach. So we're seeing that water quantity alone is no longer enough, and engineers and the entities that we as engineers design for are looking to ensure a greener approach and want to make the most of the wider benefits of a sustainable drainage system. And so with these moving demands and with these drainage design challenges, we needed to create a better solution to provide the drainage design tools for now and for the future. And so that is InfoDrainage. InfoDrainage is our next generation drainage design platform. It has a graphical interface, it has highly detailed green infrastructure analysis and streamlined workflows. And we've really built it so that you can design creative, sustainable drainage structures as true to life as possible, as well as improve your ability to model and communicate increasingly complex drainage schemes. And I'll pause here too to mention that Innovyze has a long history with drainage design. So our micro drainage product dates back to the 1980s. And so since then, we've been able to kind of harness that 40 years of industry research, of development, of industry knowledge, and harness it into InfoDrainage. So how does InfoDrainage solve those drainage design challenges? For the remainder of this presentation, I'll go through these four main mechanisms by which InfoDrainage allows you to address those drainage design challenges that we mentioned earlier. And we'll start with project efficiency. And really, this aspect is kind of the most important if not the most prevalent, that underlies kind of all aspects of info drainage. So I can evangelize green infrastructure as much as I want to, but if it's not an efficient tool, if it's not helping you guys be more efficient with your workflows, then there's not really a point. So drainage design is on that critical path, and unfortunately, it typically comes at a point in the project where it comes at the end of the project. So your timelines that are tight are already really, really strapped for resources. And so new efficiencies can help your organization gain a competitive edge. We know that working between multiple data sources, multiple design tools, different calculators, different spreadsheets is really a suboptimal solution. And project rework and slow turnaround between stakeholders adds risk and uncertainty, which can lead to poor quality deliverables, days wasted, and deadlines missed. So by creating a dedicated graphical drainage design platform where you can create and modify those designs on plan, and being able to leverage multiple data sources, enable you as a drainage design engineer to deliver your projects reliably, efficiently, and as a part of a comprehensive solution. So let's talk about the graphical platform of InfoDrainage. So when I give live demonstrations of this product, I always start by mentioning the ribbon toolbar at the top. So it's really intuitive. And when I started at Innovyze, this product was really the first one that I was able to pick up and run with just because of that guided user interface. So you can really, just like working your way from left to right across your screen, you can start at project import, load data sources in, work through all the calculators and analyses, and then export your project. So you can go from having a blank slate to a finished drainage design really, really quickly. And so we'll go ahead and take a look at that, what that interface looks like. And so again, there's that modern ribbon toolbar that kind of helps guide the user through typical workflows. All the drainage design calculators, wizards, and processes are included inside the user interface or this graphical platform. And here you can see an example of our network design wizard, which guides the user through the right sizing and network optimization workflow. All recommendations to the user are then clearly highlighted and easy to review, with no changes being made without user confirmation. So you have control over what's being updated and what's not. And then these full network details can also be reviewed in tabular format, just to keep everything organized. And we also have these storage requirement calculators that are built in, and results can be used quickly to create or modify structures. So in this example, we are using that calculator to resize a cellular storage structure. And so once we accept those changes from the calculator, we can see the results applied automatically to both the detail of that storage structure and on the plan layout. Moving on to simple data import. So data is obviously generated in many formats, and InfoDrainage essentially just helps you make use of what's already available so that you're not having to manually retype any information, and just, again, enabling you to really utilize anything and everything that you already have available. And so there's a wide range of different data formats that can be seamlessly imported to create and update those designs more quickly and efficiently. And this allows the user to better utilize existing data for a site and remove some of that manual workload. So being able to make use of that existing data supports a streamlined design process. And so with this data available and quickly imported, it'll enable tools like the deluge function to identify blue-green corridors on a site. We'll go into that deluge tool a little later, but you can see how easy it is to add imagery and surface data. So along those lines, there's also this streamlined design process within InfoDrainage. Again, just being able to more quickly set up a model by intelligently importing that design data, being able to leverage CAD and GIS, and not only have those things loaded as background imagery, but to actually apply them, import them intelligently so that you can apply them as aspects of your drainage design model. So again, there's a wide range of those different data formats that can come in. And one key task is the definition of catchment areas or inflow areas, and then the assignment of these areas to the structures that are going to drain that water. So here you can see that we're importing this CAD file, which contains those catchment areas, and we've made this process faster, and so these can be imported directly. You can select which layer those are on via that import wizard. And so these catchment areas are now loaded. They're ready for assignment, which can be done directly on the plan, and you can start to update the characteristics of those drainage areas as well. And so this is the concept to construction idea kind of that I was talking about earlier. And so basically because of those tools within InfoDrainage, we're given the flexibility to continually modify designs on plan as we move through different iterations, as we move through different phases and different level of detail. And basically it gives us a fast and iterative drainage design workflow. So from the outset of your design process, it's easy to lay out items graphically on plan. And so in this example, having already created an outline pipe network, you can see how easy it is to create green infrastructure elements such as a bioretention area or swales, and then connect these design elements to rapidly create those initial drainage design plans. So here you can see that we're using this add train tool to lay out some swales graphically on plan, and being able to make use of that supporting site data is crucial, but it's also rarely static. So we're refreshing that background CAD file now. You can see that that housing layout has changed, and we can easily relocate those swales and use that new area that we have for additional stormwater control elements, such as a drainage design or ponds, as you can see here. And so we can also continue to add more detail to that design incrementally. And so as we create these new features, we can also define the connectivity between those structures. And so in this case, we're adding the incoming connection between the existing pipe run and our pond, as well as updating the outlet of that pond as well. And so the flexibility to continually modify things on plan, you can see how big they are, you can see where they're going to fit into your site, helps to support that fast iterative drainage design workflow. Okay, so we'll move from project efficiency into optimized sustainable drainage design. So we mentioned earlier that designing for water quantity isn't really enough in the drainage design space anymore. And so for the sake of our planet and for the sake of the entities that we design for, we also need to take into consideration all four pillars of sustainable urban drainage design. And so that includes water quantity, of course, but it also includes water quality, amenity, and biodiversity. And so this is something that I personally get really excited about. When I first started my engineering career, kind of doing some green infrastructure design calculations, I had these starry-eyed hopes of developing beautiful green infrastructure elements that would add to the overall placemaking element of a site. But it turns out we didn't really have an efficient and accurate way to design those things that I wanted to with traditional spreadsheet methods. But InfoDrainage and the tools therein allow you to visually represent these green infrastructure elements, model them accurately, and optimize them without being over conservative, and actually allow you to get those drainage designs approved and built. So one of the capabilities that assists with low impact development practices is being able to visualize the existing blue-green corridors or the existing drainage ways from the outset of your design. So this obviously allows you to support better spatial planning and also can help save you money on things like earthwork by utilizing those natural low points, those natural drainage way corridors. And this visualization aspect is also important for communicating your results to non-technical stakeholders. So let's take a look at what I'm talking about here. So identifying those overland flood flow routes helps support that better spatial planning. And so this can be done by leveraging the existing topography that you have available for a design within InfoDrainage. So this is that deluge tool. These are kind of the typical results that you might get from running that tool. And having that surface data and having that background imagery is really all we need to give us a compelling analysis. And then you can update the thematic elements of that analysis so that you can and easily change them so that these results can be quickly shared with stakeholders via a simple export, whether that's to an image or to a CAD file, for example. And this deluge tool I also like to mention can be a great QC tool on a finished grade, just to take a second look at where water will go if for some reason a drainage feature were to fail or get clogged. So you can bring in your finished grade surface, run that tool on it, either send it back if you're seeing ponding areas in your buildings, or just kind of give you that visual element that you can include in your drainage reports and share with different stakeholders. And so efficient system layout, we obviously had that whole section about project efficiency earlier, but again, it really kind of underlies everything, including the optimized sustainable design features within InfoDrainage. And so one thing that's really nice about having these green infrastructure templates on plan and doing those calculations in one place is that I know when I was first starting out as a drainage design engineer, it was really difficult for me to use a calculator, use a spreadsheet, learn that I needed to have a bioretention facility that was 10,000 cubic feet or whatever, and then just simply by looking at the plan in my CAD drawing, understand how this is going to fit and how this is going to work. And so with InfoDrainage, it's really easy to drag and drop different features, different templates onto your plan, tweak the footprint with that background information, and check that those volume and discharge requirements are being met all within the software. So in addition to our pipe and manhole design that we saw previously, we can use the Add Train tool to quickly lay out multiple LID structures. So these templates can be made to make this process quicker and more accurate, incorporating pre-configured details of the chosen structure. So including things like underdrain and overflow templates within the detail, for example. And so you can see here how easy it is to lay out those swales and connect them to your previously created pipes and manholes. We can also create and modify the inlet and outlet conditions associated with the swale. So in this case, we're locating our underdrain and our overflow on plan, and connections between these structures can also be created and modified, as well as connecting those inflow areas to the draining structures within your design. And so we're also able to visually modify the layout of the structure to better represent what those structures are going to look like on the site. So here we're adjusting those footprints of those swales, making them as true to life as possible, so that what you design is what gets constructed and what gets pushed to your CAD drawings, to your Civil 3D drawings when you actually make those, print those, and send them out. And so it really just gives you a better feel for the overall site layout as well. Cutting edge representation and analysis of green infrastructure and traditional infrastructure for that matter. So ensuring that you can accurately represent and analyze these elements and analyze complex drainage design and stormwater controls is fundamental to InfoDrainage as well. Following low impact design practices and mimicking the original hydrology of a site often requires multiple interconnected green infrastructure elements connected. And so if you're trying to design these interconnected elements with a traditional spreadsheet, you really can't do that without making assumptions about their performance if you're designing them and sizing them independently of one another. And so this guesswork really leads to over conservative estimates, and you might end up taking up too much space on your site, or worse, if you're not being over conservative, you might end up with undersized elements that fail once actually constructed. And so InfoDrainage offers improved hydraulic representation and ensures a sound understanding of how the water passes through interconnected LID structures, and that's really central to the hydraulic engine. So the engine also gives consideration for the different levels of filter media and the effects of those structures slowing down flows. So we can see that in detail in this visual long section view. And really what this animated profile helps demonstrate are the benefits and the performance of all the structures being used within a design across a site. And so in this example, having already run an analysis on our design, the results can be visually replayed in this animated profile view, which helps to provide a better understanding of how the design is performing and how these different elements affect one another as they start to fill up, as the upstream pipes start to fill up, and that sort of thing. And so these graphical feedback from the results, such as pipe capacity being exceeded or flood risk level warnings, can be shown both on the long section as well as on the plan view directly, which helps to inform the user that a specific area of a design might need further optimization during certain storm durations. So now we'll take a look at what those look like on plan. I mentioned that you can see those in the profile view, but you can also turn them on and just view the entire site as a whole, giving you quick access to the areas of your drainage design that might need more optimization. So now we will move from talking about green infrastructure and sustainable drainage design to enabling BIM workflows. So since Innovize's acquisition by Autodesk, naturally the most common question that we started to get was, are your products interoperable with Civil 3D? And in the case of InfoDrainage, that answer was yes, even before the acquisition. So we all know that drainage design will often involve iterative changes throughout the project, and that these iterative changes, these updates, can be really painful and really time-consuming to address. And we know that these designs need to be taken from concept to construction, and we need to make sure that our drainage design fits into all other elements of the site. And so what I mean by that is that we need to do some sort of clash detection analysis to make sure that you're not running into electrical, potable water, everything else that's going on in your site. And so we need the drainage design and all other elements in one place at the end of the day, which for most engineers ends up being a Civil 3D drawing. And from there, plotting all those things and submitting them as construction documents. And so because one of the most common questions I get about InfoDrainage is the interoperability aspect of InfoDrainage and Civil 3D. I won't talk too much about why it's important. I think that's pretty widely understood, but we'll just kind of dive in and show you how that's done. So there is a seamless data exchange with Civil 3D. So you can start within Civil 3D and benefit from all the tools and all the design tools that are already offered within that software, and create your design layout there if you wish. So in this example, the design is just at the early stages of an initial pipe layout. And so utilizing that dedicated InfoDrainage Civil 3D ribbon, you can initiate an export of your CAD data to InfoDrainage. And this export wizard guides you through that process in a streamlined fashion. And so from here, that design can be opened directly within InfoDrainage. That data can be reviewed in detail and further enriched with supporting background site data as desired. And the tools to review that data within InfoDrainage graphically on plan, via long section view, or in detail in tabular view, provide the user what you need to begin optimizing and designing and creating your drainage solutions. And so then this slide kind of just highlights some other things, but essentially what you can then do once you've taken having completed some initial work in Civil 3D, exported that to InfoDrainage, completed your drainage design there, you can bring that back into Civil 3D via a similar guided import process. So this round tripping of data gives the engineer greater flexibility in terms of their workflow, and using this parts mapping enables faster 3D object representation. And so in this example, you can see the visual representation of the design in a couple of the native Civil 3D views. You can see that the pipe network was brought in, but so were the stormwater control structures. And those are accurately represented in the surface as laid out on plan in InfoDrainage. So further design iterations within Civil 3D are minimized by maintaining those correct connections, by maintaining those inlet and outlet locations from the graphical plan that you already completed in InfoDrainage. And if we do want to make design changes in Civil 3D, we can then update the existing InfoDrainage files by following a similar export process. And so this can be repeated as many times as is required, round tripping the data easily between those applications. And there's a couple things that I want to note about the InfoDrainage and Civil 3D integrations. So first thing is when you update the Civil 3D pipe network with your InfoDrainage drawing, the Civil 3D pipe network is updated and your references are maintained. So what that means is if you start within Civil 3D, you have a Civil 3D pipe network, bring it to InfoDrainage, make some changes, then you want to bring it back into Civil 3D. The elements are not replaced, they're not duplicated, they're actually updated, and your references, including alignments, surfaces, labels, are maintained. So you really start to minimize a lot of rework there. So if you have profiles already set up, you don't have to go through and delete duplicate pipe elements. You already have those references so that you don't have to go back and recreate them. And really, you don't have to risk any drawing integrity there because of that network being updated. And the second thing I want to note is that Innovise is now Autodesk. And so that's obviously why I'm giving this presentation. That's why I'm giving this presentation on Autodesk letterhead. But really what I mean by that is our development teams are now officially collaborating and working together. We're under the same umbrella. And so we can really expect very powerful improvements to these workflows on top of what we've already accomplished before the acquisition. And we know how important these the Civil 3D and InfoDrainage interoperability is to our customers, and it's really is one of, if not the top priority from an InfoDrainage development standpoint. And so that's really exciting. Okay, and so that is our enabling BIM workflows. And we'll now talk about reviewing data, reviewing results, and gaining quicker approval from regulatory agencies. Before I continue, I'm going to take a quick sip of coffee because my throat is drying out. Okay, so getting approval quicker. When you're working on a drainage design, ultimately it will be sent to an approving body. It's the responsibility of the engineer to provide that approving body with a package that they can confidently sign off on, that they can easily understand, and that they can trust meets their local regulations. And of course, they want to do this as quickly as possible. And so the three features of InfoDrainage that I'll highlight that help achieve that goal of gaining quicker approval are user-defined audit reporting, so that you can easily verify that your designs meet certain criteria. I'll talk about customizable reporting outputs to easily deliver your project results. And I'll talk about the ability to graphically and accurately demonstrate exceedance flows. So starting with dedicated audit reporting. InfoDrainage's streamlined review and audit processes are easy and repeatable enough that you can use and edit them throughout the design process. So you're staying on track, you're constantly checking to make sure that things are going to be approved that first time around. So whether you're an engineer preparing for submission, or if you're a reviewer who is approving those drainage designs, you can be confident that the design is meeting those requirements every time. So let's take a look at that reporting. So the audit report capabilities within InfoDrainage help to demonstrate compliance with local requirements, whatever those might be. So you can create these audit reports to check the properties of a design against a range of criteria that is user defined. So you can make it as specific as you need to your local jurisdiction. And here you can see how you can customize that report manually in the first instance, but of course you can also you also have the ability to save these audit reports as a template, reducing the need to re-enter data and allowing quicker submission to multiple authorities with differing requirements. And so if all that data and results already exist, there's no need for additional analysis to be run again, which saves the engineer time. And so here we can see the audit report outputs, which allow you to get into the detail of that audit's findings. And we can also validate and review those failures directly, and you can just check that box, press OK, and they'll be accepted, which just having those suggestions allows you to quickly revalidate and then rerun and perform the audit again. So next, we will talk about customizable reporting outputs. So theoretically, the difficult part of drainage design is the drainage design itself. You know, that's what we went to engineering school for, is to do the engineering work. But oftentimes we're stuck wasting our very valuable brains, and I mean literally valuable if you're talking in terms of billable hours, of course, wasting our time copying and pasting results into the necessary formats. And so InfoDrainage's customizable reporting outputs give engineers tabular and or graphical reports that can assist in driving faster design sign-off. So you can, again, spend more time designing and less time copying and pasting. So this is the customizable report builder, which allows you to create templates similar to the audit reporting tools. So you can have these reports for easy reuse. And it allows the user to define the report specifics and layout. And so this also provides flexibility to cater for meeting regional review specifications. InfoDrainage also helps to add clarity around communicating all the details of that design and showcasing how that design works. So we understand that drainage design can be complicated, but if you're able to clearly communicate that design, for example, here we're showing where water enters a structure and what type of outlet structures are being used, as well as the detailed dimensions, which really enables people to get a view quickly of what you're trying to communicate and what you're trying to accomplish with your drainage design. We also wanted the pipe and manhole network to be more easily communicated with easy to interpret manhole and pipe schedules, as well as graphical graphs of those different elements and the detailed results. So the last thing I'll talk about is demonstrating exceedance flows. And so I have this feature of InfoDrainage listed under gaining approval because some regulatory agencies are starting to ask for overland flow mapping in the event that a drainage structure does overflow. But really, this feature is something that can take your drainage design to the next level, both in terms of accuracy and in terms of instilling confidence in your clients that your design is going to function as intended, even during more intense rainfall events that we're starting to see as a result of things like climate change. So InfoDrainage contains a coupled 1D and 2D simulation engine that can show where these overflows will go should they exit the 1D pipe network system. And so this enables compliance with various regulatory standards. And InfoDrainage really is one of the unique aspects in how it demonstrates and shows the interaction between green infrastructure elements and these overland flows. So here we have an example of that 1D, 2D analysis. And so as I run the simulation, as that rainfall event progresses, and here we are showing a pretty extreme rainfall event. Again, we're kind of talking about climate change type of scenarios here, but you can see where it floods out of your structure. So as those stormwater controls are overflowing, you can see where that flow, based on the surface data that you import, is going to go. So we get that accurate representation continuing all the way to these exceedance flows, which again gives you that confidence in how your drainage design system is going to behave, and that any regulatory requirements surrounding overland flow will be met. And so that is InfoDrainage. We talked about how you can define those true to site structures quickly, dragging and dropping different green infrastructure templates onto your site, resizing them, and calculating how big they need to be to help you effectively make the best use of space. We talked about being able to analyze and optimize the system as one. So being able to connect those things, run the model, see how they interact with each other as they're in series, rather than analyzing each individual structure one at a time. And we also talked about the different visualization options. So that's the deluge tool again, that's the 1D, 2D analysis. We talked about how we can export that design data back into things like Civil 3D, and how you can also export the details of your design data into using things like the audit reporting tool and the customizable reporting options. So those can be sent to a variety of stakeholders for quick approval.